All right, further review, just so you guys know, here's how the answers are supposed to go. So, first one from page 191, number 14. For part A, that one was supposed to match this one. Should match with graph number 4. And the reason is because there is a negative linear correlation because it goes downwards, but also there's a little more dispersion in the graph compared to number 2. Part B, the R value should match with graph number 3. And the reason is there seems to be no correlation at all. Okay, that one's all over the place. Part C, when the R value is -1, that should match with graph 1 because it's a perfect line and it's a negative correlation. And then part D, the R value is -0.992, should match with graph 3. And the reason for that is that it is a negative relation because it goes down. But as compared to part A, and I don't have the pictures of the graph, but I know that one's a little bit closer to a line than graph number 3 would be, or 4, I mean. 4 might have had a couple points that were a little bit more off of it than the third one was, okay? So that's number 14. I'm gonna switch to the next one, 28. Okay, so just to remind you, for 28, for part A, response variable, or the dependent variable, is the one that measures the outcome of a result of a study, and the explanatory variable is a variable that we think explains the causes changes in the response variable. So again, we had those definitions a long time ago. However, just to remind you, then the total length is that explanatory variable. And then for the scatter plot, using your X's and your Y's, and you should have had a scatter plot that did something. Like so. Depending on your, something like that, depending on your scale. Okay. And so I would call that a positive relation just because it does flow kind of uphill. I don't have a calculator on me to do the R value. However, looking at if I were to try to find that line best fit, that's kind of a best guesstimate right there. It would flow pretty good. So that's part A, or part B, I mean. Part C, hold on here a second. Let's see if I'm missing something. Okay, so for part C, to find that R, I do not expect you to do that by hand. Please do not. We'll be using the calculator on that part. I know somebody asked me a question about what was going to be on the non-calculator versus calculator, and I'll explain that in the in Google Classroom. I will not expect you to do the R value by hand, okay? But to do the R value for that one, when you get that, it should have been something like 0.704 or close to it. Okay? Make sure you're typing everything in correctly. I've been starting to grade your guys' tests from chapter 3, and sometimes I think some people might have messed up on the putting in numbers or something. So, but anyway, then the last one, it is a positive relationship because we have a 0.704. I mean, that's a strong positive. It's not like highly strong. It's not way up there. However, it is a strong positive for sure. Okay, that should be number 28. Then next one. Get to it. It's number 20. Just make sure I'm on the right one. Yep. Okay. All right. So again, on something like that, when we're finding the least squares regression line for this one, we don't expect you to solve this by hand. I 100% want you to use your calculator. So on stuff like that, we're using the calculator to come up with it. And so you should have gotten something like 1.694x minus 142.45. Okay, when you found all the pieces. And then as far as what everything means, the slope of 1.694 means that it increases the total length by 1 centimeter, leads to an increase in the weight by that much kilograms, keeping other things consistent. Because when you think of this slope, you're thinking of it as this number divided by 1. So therefore, every 1 centimeter would equal this much kilograms to keep everything else. And then the intercept, this number, means that weight, when the height is 0, does not make sense because our weight can't be negative. Okay, so if you think about that, I mean, it'd be great sometimes if the weight was negative, but that's just not possible. Then for part C, what you're doing is you have that 1.694 times 149 minus the 142.45, and when all shakes out, you should get 109.956. And I'm going to 3 decimal places there. And then on part D, where it's asking you to find the residual, you take the 85 that they give you minus the 109.956 and get a negative 24.956. The negative residual means that the bear's weight is below average, is all. Okay, that's number 20 from page 207. And next one. Excuse me. matching one. Space in here. Okay, so that would match with that graph because all points in the regression line. So there's 100% of that. The next one, r squared equals 0.12. That would match this graph. I should have probably put this on there. Because they all lie off the regression, and it only means that there's only 12% of the variation. And then the last one for this. This graph. Because most of the points lie on the regression line, but that there's 90% variation. So the last one would have to be that r squared equals 0.5 would have to match with this graph. And again, it's got a little more variation to it. In part B, it says for r squared should match this graph again. And the reason is because 90% of the variation, 90% comes from the r squared value. You know, if you take out 0.9 and make it into a percentage, you get that 90%. And same with part C, why the r squared equals 1 matches the fourth graph is because there's 100% on there. And again, for part D, matches the 12% one because it's got quite a bit of discrepancy there. And the next one, 14. So for 14, on that answer for that, the blue point is influential because the blue regression line, including the point, has a different intercept as compared to the red regression line and significantly different slope as compared to the red line, implying that the blue point is influencing the regression. Okay, so they're shifting that around to see which one would have more influence on its regression line. So the blue point is influential. Okay, hold on. So my bad, I read that wrong on the worksheet. It should have been all the way from 9 to 11. So I gotta redo those ones real fast. Excuse me. So on part number 10, when it gives you this, so then what you're going to do is you're just going to square those to get that. So that would be your capital R squared. And what that means then is if you move the decimal point over, it's 10.24% of the variation is explained by the regression. On the next one, and it gives you R is 0.13. You take 0.13 and you square it. 0.169, which would mean 1.69% off the variation, or of the variation. R value is 0.4, 0.16 or 16%. And when I do that one, and I square it, I should get 0.8649 or 86.49% of the variation is explained by that. Okay, so sorry about that. Then going back, number 11, the blue point is influential because the blue regression line, including the point, is leaning towards the point compared to the red line. On the number 12, the blue point is not influential because the blue regression line, including the point, has the same intercept as the red regression line, has marginally smaller slope as compared to the red line, implying that the blue point is not influencing the regression. And same thing here. The blue point is not influential on number 13. But on 14 it is, because again, it goes back to comparing it to the red line, and it has a significantly different slope. Okay. And the last ones, 35 and 13. Look back at this. I think, yeah, those last ones, the 3, 5, and the 13, those shouldn't have been on there anymore. That was a part that we took off. Okay, so my fault on that. You will not need to know those last 3. Okay, so again, do not worry about the last 3 in the review. We should have taken those off because we didn't even do that section. Okay, so just to kind of give you a heads up, I know we were talking about, I was going to put it in the stream, but also put it here. I'm just going to talk a little bit about what the test is going to look like, because there were some questions about non-calculator versus calculator. So the non-calculator is going to talk about, at the first page, 1 through 6, it's going to be multiple choice. And it's going to ask you questions like, it'll give you things like, if this is the linear correlation coefficient or the R value, is that strong positive, strong negative, no linear, or something like that. And then it'll say, what's the explanatory variable? What's a residual? The least squares regression line is what? Coefficient of determination is the blank. Which residual plot is the most appropriate for a linear model? So they're going to give you some of those things. And then I'm going to ask you to construct a scatter diagram. I give you the data, and then it's going to say determine if there's a positive, negative, or no correlation. That's for 7 and 8. And on that, to be fair, there's nothing that you have to figure out. It's just draw the scatter plot, and then from there, determine if it has it, okay, just by looking at where the dots line up. And then I ask you to figure out the residual. So there's only 9 questions on the non-calculator part, okay? Then as far as the calculator part, when we get to that, I'm going to give you a table of values, and it's going to say, like, find the equation. What would be the predicted score of this? Is this reasonable? what would you get when a predicted score was that? Is that reasonable? So this is more of you're using your calculator to come up with the least squares line and such. Okay. Then on number 2 on that, it's going to say draw a scatter plot. So you get to make up your own on that. And then I want you to put a B that has influential at a high level and a high residual, and then another part that's not influential. Okay. And then number 2, it's going to give you a table of data. It's going to ask you to do things like, what's the explanatory variable? Draw a scatter diagram. Okay, so you can put it on your calculator and then rough sketch it on the page. Compute the linear correlation coefficient. Compute the coefficient of determination. Does there appear to be a linear relation? Yes or no? Find the least squares line. Interpret the slope and y-intercept. Predict if this. Would this work if it was that? Draw the residual plot. Again, you can use your calculator for the residual plot, but just then from there, rough sketch it on your page. And then from there, it'll ask you some questions. So that's what it's going to ask you on the different parts. Okay, so again, never going to ask you to do any of that stuff by hand. So on the non-calculator part, it's like multiple choice, fill in the blank kind of type things. Rough draw some scatter plots and see what they look like. Determine if it's positive, negative, or no. Calculate a residual, which that should be, I give you, I think, everything that you need for that. So, okay. So don't worry about it too much. I think you'll be just fine. But kind of what my plan is that you'll have that first part on Friday, tomorrow, and then the calculator part I was going to do next Tuesday just because I didn't want to give it to you Monday. But on Monday, I'll give you a 5-1 just to let you guys know, start you off and get you started on chapter 5. And then we'll do the calculator part on Tuesday. And then you guys have spring break for the rest of that week. So, yeah. Anyway, keep sending your stuff. You guys are doing great. I miss you guys, and I will see you soon. Ciao.